That hole that you see on the upper part of the screen is the first, that's what they call the idle hole. And as the throttle plate opens up, we'll see a transition hole. That's what we want to just slightly expose. One side of the motor is exposed to vacuum. The other side of the motor is exposed to atmospheric pressure. So what we want to do is we want to allow that second transition hole to deliver just a little tiny bit of fuel. See that second transition hole? There's two of them there on the upper part of where my finger's at, right in this area, which on a steel saw is on the top, and gravity affects that. Here's the metering area. So fuel is going to be kind of like filled in this area. Here's the metering diaphragm. Pump diaphragm is down here in this area where the fuel comes in. Well, no, that's the impulse line, but this is the fuel. But it all goes in there, and it's controlled by a needle valve right around, well, pretty much right here. But what we want to talk about is the position on these saws, these 460s, that seem to affect something. So what we have to do is look at those transition holes. We also have like a little half moon thing cut out of the throttle plate that allows air to pass over top of this auto orifice or hole or whatever you want to call it. It's right there. But I guess to make a long story short, you have to have the auto adjustment that works the throttle plate opened up enough it's on a ramp. It hits this and works the throttle plate enough to slightly expose that second transition hole to vacuum. And at that position, it'll start delivering fuel. And I've already got it pretty much in. I mean, it'll be a thing where you know, the saw will be idling fast all of a sudden. Well, not all of a sudden, but it'll be idling fast as you screw that in. That's your idle screw. So as you screw it in, you're opening. It's like you're giving the throttle or the motor throttle. So it's going to speed up, but you're going to reach a point where it actually starts to slow down. And that is the position that this throttle plate is in, that it starts to slightly expose that next transition hole to vacuum, and it starts to deliver fuel. That next hole. That one, right there, on that throttle plate, see it? It opens and it closes it. That little hole right there. And that is the position that we want to pretty much focus on. We want it just barely flowing air past it. And I talked about gravity. With the steel, and I talked about those saws stalling all of a sudden if you were to like move them suddenly. Pick them up. Tip them forward. See, tipping them forward or turning things on the side changes gravity with the relationship with where fuel's at and where it's going to come out at, which are those holes. So what I would like for you to do is open up the low adjustment about 1 1/4. Turn this thing, the throttle plate, until it just barely starts to expose that first transition hole. Just barely, which is like 3/4, 7/8, all the way full open. But you'll reach a point where it slows down instead of speeding up. You're used to this, which it does because adding air to the mixture speeds things up, just like the throttle does. But what I'd like for you to do is pretty much, oh shit, I've got a lot of time into thinking about this and how to state it to you, but this is your throttle plate, your auto adjustment. You can have your low adjustment right around 1 turn out. And you keep screwing this in and opening up this throttle plate, but you haven't opened up any fuel orifices to give any more fuel until you reach that point. That point right there. That's where you have to get them at. That point. See that one? That second one? To where it is just kind of like bubbling a little bit of fuel out. And then the motor will start actually slowing down. Even though you haven't leaned the low adjustment any, it'll just automatically start slowing down. And you think that you are, well, I'm turning the auto up. I just keep turning the auto up. And the auto will go up. It'll go up. But there is a point that it will start going down. And that is the point that you need to be at. You have to have a lot of air flowing past these things to make up for gravity and moving things around and tipping them forward and tipping them back. Now, if you get it to that point, and I've told you to turn the throttle plate very, very open to the point that the auto actually starts to fall down. It'll speed up, it'll speed up, it'll speed up, then it'll start to fall down. Then at that point, it almost won't hardly do anything for a little while. This throttle plate adjustment, the auto adjustment, won't hardly do anything. Because the more that you open it, the more it starts delivering more fuel. So you have to mess with your low mixture screw after that. So it's like a little combination, but what I do is pretty much start at 1 turn out on the low side, and then keep screwing this, the auto adjustment, until it starts to expose that second transition hole. Until it starts to expose that second transition hole. There it is. You see that second transition hole? That second one right there. Until it starts delivering fuel, and that is what is causing the idle to come down at that point in time. That second transition hole. Because you're richening at that point in time. That hole. One hole, two holes. 1 and 2. Those are the ones right there. It's a real pain in the ass. Oh, that's a much better view. Those 2 holes. That second hole is the one that is affecting things. So we have to uncover it just a little bit. And at that point in time that the idle starts to come down with the throttle plate, then you do your fine adjustments on idle with the mixture screw. And I would say, I can't say for sure with your elevation what that would be. But I can tell you that there is a pretty good difference between a standard bore and the big bore. The big bore likes more fuel. It likes a richer adjustment setting on the low. And the way I have the one on the saw that you have set up, the high is, well, let's look inside here a little bit at the other jets. There are other holes. There's one. It's hard to tell, but there's one here on the side that's fixed in this metering area that I've really bored out for that saw, and I may have made it a little bit too big, but don't be scared if you have to turn your high way in. I mean, like, close it off if you want to, if you get in higher elevations. But I hope this helps. I think we're getting somewhere with this, but unless you do have an air leak, or that fuel line, whenever it leaks, it's because it's been pushed up all the way into this curved area. And you'll know if it leaks if you take, you get down to the carburetor, and all you gotta do is just like put a little pressure on it. The fuel tank is pressurized, and it'll end up leaking out. It'll leak out and run out the bottom of the saw eventually. It will. Or you can see it bubbling out in this area right here where the fuel line goes on this barb fitting. I don't know whether it's because of the barbs. I don't really know for sure. It is a problem that I had with that particular saw, and I thought the damn thing had an air leak. I was like, well, shit, it ran great one day, and I was like, well, let's check this. And it was leaking fuel right here, and I had to trim a little bit the way that the fuel line fit on this barb fitting. But I don't think that was it. I don't think that was the problem that you initially had. If you went to turn down the idle and the saw wasn't really warm, it's going to turn the chain whenever it's warm. Or not warm, but cold. And you started to close the throttle plate, then what you actually did was cut off fuel at the same time, because you covered up that that first transition hole. you did this. That's delivering fuel. See 1, 2 holes? You closed it off. And you actually, it was almost like turning or leaning out the low adjustment. Hope this helps. It's 15 minutes. Been thinking a lot about how to say it, and I don't know that I said it all right, but I hope this is better in text.